Okay, so hello and welcome back, guys. Today we're going to start our new topic, and that is the process modeling using data flow diagrams. So, what is a process modeling? A process modeling is a technique for organizing and documenting the structure and flow of data through a system's processes and the logic policies and procedures to be implemented by a system's process. So, in the systems design phase, we build what is called a physical model that describes how the system will be constructed. Data and process modeling involves three main tools, that is the data flow diagrams, data dictionary, and process descriptions. So, system analysis process model consists of data flow diagrams. A data flow diagram is a tool that depicts the flow of data through a system and the work or processing performed by that system. Synonyms include bubble chart, transformation graph, and process model. So, system analysis uses many graphical techniques to describe an information system. Sorry. One popular method is to draw a set of data flow diagrams, or DFD. A data flow diagram uses various symbols to show how the system transforms input data into useful information. So a DFD shows how data moves through an information system but does not show program logic or processing steps. A set of DFDs provides a logical model that shows what the system does and not how it does it. This distinction is important because focusing on implementation issues at this point would restrict the search for the most effective system design. Okay, so there are only four symbols and one connection. We'll pass by one by one. Let's get an overview of them. So the rounded rectangle or oval represents the process or work to be done. The squares represent external agents, in what is called maybe the boundary of the system. The open-ended boxes represent data store, sometimes known as databases, and correspond to all instances of a single entity in a data model. And the arrows represent data flows, or inputs and outputs to and from the processes. So here are four symbols. This is the symbol for a process, the rounded rectangle, the arrow show a data flow, open-ended boxes represent data store, and the boundary or external entity is shown there with the square. So starting with the process symbol, so a process receives input data and produces output that has a different content, form, or both. For instance, the process of calculating pay uses two inputs, pay rate and hours worked, to produce one input, that is the total pay. So process can be very simple or quite complex. In a typical company, processes might include calculating sale trends, filling online insurance claims, ordering inventory, verifying email, and stuff like that. So process contain the business logic, also called the business rules, that transform the data and produce the required results. So the process name identifies a specific function and consists of a verb and an adjective if it's necessary, followed by a singular noun. Example of process names are apply rent payment, calculate commission, assign final grade, verify order, and fill order. So in DFDs, a process symbol can be referred to as a black box, okay, because the inputs and outputs and general function of the process are known, but the underlying details inside and logic of the process remain hidden. By showing processes as black boxes, we as analysts can create DFDs that show how the system functions but avoid unnecessary detail and clutter. So when the system analyst wishes to show additional levels of detail, he or she can zoom in on a process symbol and create a more in-depth DFD that shows the process's internal workings, which might reveal even more processes, data flows, and data stores. So in this manner, information system can be a long series of increasingly detailed picture. So in the end, you should be left only with logical processes that perform computations. For example, calculate maybe grade point average, make decisions. Maybe example there will be determine availability of, let's say, ordered products. Sort, filter, or otherwise summarize data. Organize data into useful information. For example, generate a report or answer a question. Trigger other processes. Example, turn on the furnace or instruct a robot. And use stored data, that is create, read, update, or delete a record.